In the previous two lessons, we learned how to create three-dimensional bodies and how to refine them. In this lesson, we'll learn about parametric modeling, joints and motion, and rendering and animation. And you'll see that all of them are fairly easy things in spite of their names. Let's start with a sketch. Select the horizontal plane, draw a rectangle. Select the circle, draw a circle of 10 millimeters diameter, press return and return again. Now, let's say I want the long side of this rectangle to always be twice the short side. So I can go under my sketch menu, select sketch dimension, and first determine what the dimensions are. I'll click on this dimension and then drag out and then click again, and that gives me the number 40 millimeters. I'll leave it as is. I'll press return to get out of it. I'll click on this dimension. I'll drag it out. That says 90. I click, and I don't want it to be 90. I want it to be twice 40. So what I can do is I can click on 40, and that'll change that number to a parameter called D2 within this one. And I say multiplied by 2. Press return, and that'll make this dimension 80, which is twice 40. Let's say I want my circle to be always centered in the middle of this rectangle regardless of the dimensions of the rectangle. So I can click on the center of the circle, and on this side it'll measure the distance between those two areas, and I'll drag it out, click. That distance is 20. I don't want it to be 20. I want it to be half of this side. So I click on 40 and divide by 2, press return. It turns out to be 20, but now it's a function that's related to this. Same thing with centering in this dimension. I will click on the center of the circle, click on this side over here, drag it down. That distance is 60. I click. I don't want it to be 60. I want it to be half of 80. So I click on 80, divide by 2, return, and now I have a fully constrained sketch. I press escape to get out of my dimension tool. Now if I want to change the dimensions of the sketch, I can simply go on to 40, double click on it. That's my driving parameter, which means that it drives all the other dimensions in the sketch, and I can change that, let's say, to 21, and press return, and now it has changed this dimension to 42, and it has kept my circle centered within the rectangle. Now I can stop my sketch. Let's go ahead and extrude this. Press on extrude. For the profile, we'll select this and extrude it, let's say 30 millimeters. Press OK. Let's also extrude the circle at the bottom of this. Let's show the sketch and extrude the circle to create a little cylinder. Make sure it's a new body. Press OK. Go back to the home view. Let's say I want the face of this rod to be attached to this side over here. Well, I could do that using the move command by moving this rod out, flipping it over, and trying to center that face with this face over here. But that would be quite cumbersome. There's an easier way to do it by using joints. And you'll find joints under the Assemble menu over here. Now, a joint is a motion relationship between two components. For example, this rod and this block. Except that right now, I don't have any components. These are simply bodies. So if I go under my bodies, I'll see my block and I see my rod. I need to redefine these as components. So I right-click onto body 1 and I say create components from bodies, and you'll see created component 1. And I'll do the same thing with body 2. It has created 2 new components. Within each component I now have my original bodies, the rod and the block. I can rename them. So that's the block component, and this is the rod component. So the nice thing about components is that, first of all, you can grab them and move them, which you cannot do with bodies. And anytime you move a component, you'll get this new item in the menu bar that will ask you either to accept the new position, which is capturing the position, or to revert back to your original position. I'm going to revert back. Now I can simply snap this face onto this face by creating a new joint. I'll define the type of motion I want. In this case, I want it to be a rigid joint or a weld. I select the surface that I want to move first. So I'll click on this little circle or coin on top of this surface. And then I will select the surface onto which I want to attach the rod. And I can attach it anywhere where you see this coin, but the coin tends to snap in certain positions. In this case, I'll attach it to the center coin. And it does this little dance to show me that I've created a rigid joint. I can move the origin of the joint in or out. I'll leave it at 0 and press OK. Let's create a second joint. Let's first create a new sketch. Go to the sketch menu and go to polygon, inscribed polygon. Select the top surface of our block. Select on the center of the hole and inscribe a polygon that fits perfectly into our hole. Press escape. Stop sketch. Let's extrude that polygon into a hexagonal rod. And make sure it's a new body. Say OK. Now I want to create a joint between the top surface of this hexagonal rod and the bottom of my hole. Well, first I have to redefine this rod as a component. So I go to body 3, create component from bodies. I'll rename it hex rod. And now I'm ready to make a joint. I say joint. Say let's make it a sliding joint. So I'll first define the type of joint that I want, a slider. And I will click on the surface that I want to move first. Then I'll expose my other surface, which is right over here. And you see that I've created a sliding joint. There are different kinds of joints I could create. I can change that to a revolute joint. You can see that it rotates along the z-axis. I could change it to a cylindrical joint, which is a combination of a slider and a revolute joint. So it rotates and slides along the z-axis. I could change it to a pin slot, which rotates along the z-axis but slides along the x-axis, or a ball joint, which freely rotates along multiple dimensions. So I'll go back to my slider joint and press OK. Let's go back to the home menu. To create components, you're not limited to your existing design. You can import components from other designs that you have previously created. In lesson 2, we created something called pointy. So let's go back and retrieve it. You go back over here to your data panel. You click on it. You'll find pointy. Right-click on pointy and say insert into current design. It gives you a warning that I have to save this file before I can import anything into it. So let's do that. I'm going to save this. Let's call it test. Save. All right. Now I will insert my pointy into my current design. Let's move it back a little bit and say OK. Now the first thing I'll notice is that the shaft of my pointy is way thicker than this hole into which I want it to slide. Let's go ahead and measure some dimensions to see what kind of modifications I have to make. I can go to Inspect, pull down Measure, and I can just click on this circle here and it'll give me a diameter of 20 millimeters. I'll close that. Let's measure the diameter of my hole. Inspect, measure, and that diameter is 10 millimeters. Close it. So I need to expand my hole to allow the shaft of the pointy to fit into it. And this is very easy to do with parametric modeling. I'm going to go to Modify and go to Change Parameters. It'll give me a new window in which I have my design called Test Version 1. I open that design. I have everything in my design within this window, including my original sketch. I open that sketch, and I'll see all the various dimensions of the objects in that sketch. You'll remember that the diameter of my circle was 10 millimeters, and I want to increase that to fit the shaft of the pointy, so I'm going to increase that to 20. And I click out of it, and you can see it increased the diameter of my circle. Well, now I notice that now the walls are too thin to accommodate this big hole, so I want to change that. Remember that I had used this dimension as the driving dimension, and that I had set that to 21 millimeters. I'm going to select that and change it to 30 millimeters. Click out of it, and now that you can see that it not only increased that dimension, but also increased this dimension to keep it twice as much as the original one. I'll press OK. And you will see that it has also changed the thickness of my original rod and my hex rod, because everything was based on the parameters specified in my original sketch, which I have now changed. So that's the power of parametric modeling. So now I can easily fit this shaft into this hole. I'm going to create a new joint between these two components. Notice that when I imported the pointy, it imported it as a component, not as a body, which is great. You can see I can open it. I'll see the body within the component. So I don't have to do anything except to start the joint process. I click on Joint. I select the component that I want to move. I'm going to expose the bottom face of this shaft, and then I have to select where it wants to go, and I'll select this hole over here, press on that coin, and I can animate that motion. That's a slider joint. I can change that into a cylindrical joint, and I'll press OK. In order to see the joint movements by cursor manipulation, I need to fix my block in space so it doesn't move. And it's very easy to do. I'll go to the block component, right click on it, and say ground. Now my block has been grounded, and now I can grab my pointy and slide it up and down. I can revolve it. Let's go to the front view. I can do the same thing with the hex rod. Notice, however, that these movements are not realistic because my pointy object can go through my block. In order to make it realistic, I'm going to go to the Assemble menu and say Enable All Contacts. This way, anytime something solid contacts another solid, that motion will stop. So now you can see it won't go through my block, and I can revolve it. And furthermore, I can drive the motion of one joint with the motion of the other joint. So you can see how my hex rod, I can snap it onto here, and it'll drive my pointy, and I can do the same thing over here. So let's get rid of this design and open our jar model from lesson 2. Go to your data browser, find your jar lid model, and double click on it. Then close this. All right, go to the browser and look at your bodies. We have a lid and we have a jar. We want to turn each of these into a component. And now we can create a joint between these two components. Go to joint, make it a cylindrical joint because we want it to rotate and descend at the same time. And let's look at the bottom view. Select the joint center of the object you want to move, which is the lid. That'll be the bottom surface of the lid. And select the second component. In this case, let's center it on the bottom of the jar. We can always raise it later. All right, now let's go to the front view. Let's raise it from the bottom of the jar to the top of the jar. Let's look at the top of it. The lid is flipped the wrong way, so we can flip it using this tool, and then look at it at the front, and then raise it up to the starting point. So we want the screwing to begin right over here, and we can animate it, stop the animation, and say OK. Now we need to better define the behavior of this joint, so we go to Assemble and go to Motion Link. A motion link is a very useful thing. It defines the motion relationship between one joint and another joint. It's very useful if you want to, for example, use one gear to drive a second gear. You select the joint that you want, or the joints that you want. In this case, we only have one joint, which is our cylindrical joint. But a cylindrical joint is really the combination of two joints, a revolving or revolute joint and a sliding joint. So we can relate one of these motions to the other one. So you link within the same joint, okay? And it'll allow me to link the sliding component to the rotating component. So basically I want for the joint to slide 20 millimeters. And within those 20 millimeters of sliding, I wanted to, let's say, rotate 3/4 of a turn, so I changed that to 270 and press OK. Now I'm going to go to my jar, right click and ground it so that I can then use my cursor to see how the lid is functioning, and it's functioning beautifully. I can look at the home view and I can turn the lid, and as I turn it, it descends. Now I want to look at a cross section of my jar to see how the threads interact as I screw the lid on. So I go to Inspect, pull down the menu and go to Section Analysis. I have to select a plane that'll cut through this jar. So let me first turn on my coordinate system. I go to my origin and turn on the light bulb. Let's go to the home view. Let's rotate things around. Okay. So I want to cut this jar along this plane, so I'll select that plane. And let's look at this view. It'll give me a cross section of the jar. I'll say OK. And now I can grab this lid and I can rotate it, and you can see how the threads interact as I do that. It has created a new analysis called Section 1. I can turn the light bulb off and I'll go back to my original view. I can turn off my origin bulb as well. I can revert to my original position of the lid. And now we're ready to look at some other workspaces. So far we've been working only in the model workspace in the past 3 lessons, but Fusion offers a whole bunch of other workspaces. The ones we'll be interested in are the render and the drawing workspace. We can create construction drawings from our design. So let's do that. And just press OK. A drawing sheet. It wants me to place the base view, which is a front view of my object. It says front over here. I'll place OK. And I'll create a drawing of the base view. Now I can go and create another base view, and let's call that the top view, and put that on top of the original view. Press OK, and let's then create a third view. Go to the drawing views and use section view, and it wants me to select the parent view, which is this one. It wants me to select 2 points through which we'll cut a cross section, and I'll press enter, and I'll deposit the section view where I want it to go and press OK. And it has created a construction drawing. I can label it and size it and create a professional drawing that I can use for manufacturing. So let's get out of here. Let's say I want to create an animation of this lid movement. I would have to first create a motion study. A motion study is basically a film of the joint movement. First, I have to select the joint. So I go back to my cylindrical joint. You'll notice that this joint again has 2 components, a sliding component and a rotating component. I'll select the sliding component, and I select 1 point first on this film line, step 1. At step 1, I wanted to start at 0 millimeters of position. I click out of it, and then I select step 100. At step 100, I wanted to have descended down to 20 millimeters. I click out of it. Because I have previously created a motion link, it knows that as I translate this joint 20 millimeters, it'll also rotate 270 degrees, so I don't have to do anything else. Notice that it created a motion study in the browser. Now I am ready to render this object and its motion study. So I go to my render workspace. Rendering is basically the process of adding color, texture, and lighting to your object to create photographs and videos. So let's select color first. Let's say I want the jar to be glass. So I can scroll up and down here. I go to glass. I select smooth glass and I select, let's say, bronze. And I grab it and bring it to the jar. If I am not happy with the color, I can just double click on here and select the exact color that I want for that glass. That looks pretty good. Press done. And for the lid, let's say I want a copper lid. So I close my glass and go to metal, find copper. Let's say I want a polished copper. So I grab that and bring it up here to the lid, and I can further adjust that if I want to, but that looks pretty good. And so I say close. Let's look at that. That looks pretty good. I can change the orientation of my object and its position. And I can adjust the lighting if I want to. I can make it brighter. I can change the position of the light with regard to my object. Or the position of the object. I could change the color of the background if I wanted to some other color. I'll go back to my original background. I can get rid of the ground, which gets rid of the shadows, or add it back on. I close, and now I'll just push render. It'll begin the cloud rendering process. It'll ask me to pick the resolution I want, and it will tell me how many credits it'll use to achieve that. Let's pick a good resolution and say render. It'll take a few minutes. We'll take a break and come back. Welcome back. It has finished the rendering process. These are all the various renderings. The most recent one is over here. I can double click on it to open it, and you'll see this beautiful photorealistic rendering. I can look at all the different renderings that it has done, and I can download it if I want to. And I can also now create a rendering of my motion study. So I go over here, it says motion study, I click on that, and then it'll begin that rendering process, but it requires a lot of credits for the motion study, and my account doesn't allow me to spend more than 16 credits per request. So I have to change the resolution to a lower resolution. Okay, 12 credits, I can do that. You guys might be able to do a higher resolution, and I'll say render, and again it'll take a few minutes. We'll come back in a little bit. Okay, we're back. We're done with our rendering. You can download the animation and incorporate it into a PowerPoint presentation or put it on your website. Let's go and see what it looks like. And here it is. This is a low resolution rendering. You could do a high resolution one. We're done with the 3 lessons in Fusion 360. You've learned a great deal. Put it to good use.